Hello students. So we have seen an important theorem based on similar triangles. That is, if two triangles are similar, then we know that ratios of areas of triangles is equal to squares of the corresponding sides. That is ratios of squares of corresponding sides. That's what we have seen in the previous video. If you have not watched the video, please watch the previous video. Now, let's start with the exercise problems. So here they have given, let triangle ABC is similar to triangle DEF, which means the triangles are already similar, and they have given us the areas. That is, area of triangle ABC is 64 centimeter square and area of triangle DEF is 121 centimeter square. If EF is 15.4 centimeter, find the value of BC. Okay, so here what they've given us is, so they've given, let me take a different color. So they have given that triangle ABC is already similar to triangle DEF, and area of AR represents area. Okay, area of triangle ABC is 64 centimeter square and area of triangle DEF is 121 centimeter square and EF is equal to 15.4 centimeter. We have to find the value of BC. Now remember, if two triangles are similar, since, or let's say as triangle ABC is similar to triangle DEF, we can say that area of triangle ABC divided by area of triangle DEF will be equal to squares of the ratios of squares of corresponding sides. That is AB by DE the whole square, which is equal to BC by EF the whole square, which is equal to AC by EF the whole square. Isn't it? If two triangles are similar, how do we take the corresponding sides? The first two alphabets here and the first two alphabets, AB by DE, BC by EF, the first and the last, first and the last. We've already seen this stuff. Now, among these three things, we will take only the middle part, BC by EF the whole square, because the question is based on BC and EF, isn't it? So, therefore, which implies from here we can write that area of triangle ABC divided by area of triangle DEF will be equal to BC by EF the whole square. Okay, let me draw a line. Let me continue the other side. So area of triangle ABC is given as 64 and area of triangle DEF is given as 121. That is equal to BC value, we have to find it, and EF value is given as 15.4. So both under the whole square. Now if the square goes the other side, it will become square root, isn't it? The square root of 64 by 121 is equal to BC by 15.4. So square root of 64 is 8, square root of 121 is 11. That is equal to BC by 15.4. We don't need this 15.4. Let's transpose the other side. So it will become 8 by 11 into 15.4 is equal to BC. So you can cancel it. 11 ones are 11, 11 ones are 11. 4 gets carried, so it becomes 44. 11 fours are 44, the point as it is. So it becomes 8 into 1.4. Okay. So 8 into 1.4, that is 14 8s are 112. So it becomes 11.2, which implies BC is 11.2 centimeters. So they are given two triangles are similar. If two triangles are similar, then we can write this relation. squares of the corresponding sides. Therefore, among that, we have to select. We'll take the middle one because the question is based on this. So let's take that, substitute the given things. We will get the required thing. So let's get into the next problem. The next problem, diagonals of trapezium ABCD with AB parallel to DC intersect each other at point O such that AB is double the CD, twice the CD. Find the ratios of areas of triangle AOB and COD. Here we have to find the ratios of areas of triangle AOB and COD. Okay, which means first we have to prove that the triangles are similar. So let's take another page. Okay, they have given us a trapezium. Let's construct a trapezium. Construct a trapezium first. ABCD is a trapezium. So we have taken a trapezium like this. Okay. So this is A. So let's take the other way. Let's start from here. A, B, C, D. The reason that I took in this manner is because AB is double of CD. Okay, so AB is bigger compared to CD, and AB and CD are parallel to each other. So let's also join the diagonals. The diagonals meet at point O. What we have to find is this area of triangle AOB divided by area of triangle COD. This is what we have to find. For that, we have to prove the triangles are similar, isn't it? So let's do that. So let's prove the triangles are similar. Okay. Let's take the triangle in triangle AOB and triangle COD. It's very clear that angle AOB is equal to angle COD because they are vertically opposite angles. That is this angle and this angle. And similarly, this angle is equal to this. Alternate angles. Whenever two lines are parallel, always go with alternate angles. That is angle DCO will be equal to OAB, alternate angles. Alternate angles. Therefore, triangle AOB is similar to triangle COD using AA criteria. Now, if two triangles are similar, now you can find the areas. So that is area of triangle AOB by area of triangle COD. Remember, you have to write the corresponding part. If you observe, angle O is equal to angle O. So O is in the middle. Here also O is in the middle. And C is equal to B. So we have made a small C is equal to A. Yeah. A is in the first place. So C is also in the first place. So we have to write the corresponding parts. Okay. So area of triangle AOB by area of triangle COD is equal to AO by CO the whole square, which is equal to OB by OD the whole square, which is equal to AB by CD the whole square. But we are not going to take all the three. We are going to take only the last part because in the question it is mentioned that AB is double of CD. So we are going to take only the last two parts. Therefore, area of triangle AOB by area of triangle COD is equal to AB by CD the whole square. Now in place of AB we can write 2CD, it is given. So 2CD by CD the whole square. So it will become CD and CD gets cancelled. So we are left with 2 by 1 the whole square. So 2 by 1 the whole square is 4 by 1. Therefore, the ratio is 4:1. So let's see it again. We have to find the ratio of these two triangles. For that, we have to prove the triangles are similar, which we have done using AA criteria. So once the triangles are similar, we'll use the result. So in that, whichever is required, we'll take that. AB by CD is required. So we have taken it. We have substituted the given values. We have got the answer. So let's get into the next question. Let's take the third question. In the third question, we have to prove that area of ABC by area of DBC is equal to AO by DO. What is given is ABC and DBC are two triangles on the same base BC. If AD intersects BC at O, show that area of triangle ABC by area of triangle DBC is AO by DO. One thing we have to look here is ABCD is not a trapezium. Even though it looks like a trapezium, remember it's not a trapezium because it is not mentioned in the question. And pictorially also, there is no line parallel to another line. That is, opposite sides are not parallel. It is not mentioned. Okay. So ABCD is not a trapezium. So let's solve it. So this is the figure. Remember what I said was, if ABCD is parallel, if they had given this stuff like this arrow mark, we could have told that that it is a trapezium, but they have not given as such. Okay. So what we have to prove is, let me take a different color. So to prove area of triangle ABC divided by area of triangle DBC is equal to OA by, let me confirm it. Yeah, it is AO by DO. This is what we have to prove. Okay. Now, let's start with the proof. Now, are these two triangles similar? Area of triangle ABC and area of, triangle ABC and triangle DBC? No, they have not given anything about the similarities. So let's try to prove it is similar. So ABC is this triangle. Let me shade it. And DBC is one which is below. Okay. Now either we have to do it by AA criteria, SSS criteria, or SAS, anyone. But there is no information about the angles. There is no information about the sides. So here we cannot prove that the two triangles are similar using any of the criteria because there is no enough data given. So therefore we have to do it in a different way. So here we need the ratios of area of triangle ABC by area of triangle DBC, isn't it? Let's use the formula. Area of triangle is given by half into base into height. Half, let me take BC as the base itself. Okay. But there is no height. You cannot say AO is the height because we don't know whether here the angle is 90 degree or not. If here it was 90 degree, then BC is the base, AO is the height. We don't know whether this is 90 degree. So let's construct one such height. So let's take AM as the height. And from here, from D, let's construct a height. Okay. This comes under construction. AM is perpendicular to BC, DN is perpendicular to BC. So in the triangle, half into BC into AM will be the height. Half into, again, BC is the base, DN is the height. The purpose of taking BC as the basis, both the triangles have got same base, so we can cancel it like this. Half gets cancelled, BC gets cancelled. Therefore, what we are left out is area of triangle ABC by area of triangle DBC. This is C is equal to AM by DN. But what we need is AO by DO. So suppose if I prove AM by DN is equal to AO by DO, then the result is done. So let's try to prove that. For that, I'm going to take triangle AMO and DNO. So let's take this as equation 1. Let's take the triangle in triangle AMO and triangle DNO. Let's prove that these two triangles are similar. Angle M is equal to angle N. Both are 90 degrees. And angle AOM is equal to angle DON, because vertically opposite angle. Therefore, the two triangles are similar. Triangle AMO is similar to triangle DNO using AA criteria. If two triangles are similar, we can say that the corresponding sides are in proportion. Therefore, we get AM by DN, the first two alphabets, AM by DN is equal to MO by NO, which is not required for us. So let's eliminate it. The first and the last, AO by DO. What is the reason for this? If two triangles are similar, then corresponding sides are in CSS corresponding sides are in proportion. Okay, so substituting this in the above result, substituting in, let me do the other side, substituting AM by DN is equal to AO by DO in equation 1, we get the required result, isn't it? Area of triangle ABC divided by area of triangle DBC is equal to, instead of AM by DN, we can write it as AO by DO, hence proved. This is one different question. We were not able to prove the two triangles are similar. So we went with the actual way of finding area, that is half into base unit, right? Using that, we have found it. So let's get into the next question, students. So the next question, if areas of two similar triangles are equal, we have to prove that they are congruent. So here there are two informations given. One is if areas of two similar triangles. So there are already two triangles which are similar and their areas are also equal. So if that is the condition, we have to prove that the triangles are congruent. That is, two triangles, areas are equal and they are also similar. If this is the case, we have to prove that the triangles are congruent. Okay, so let's do that. So let's say let triangle ABC is similar to triangle DEF. Let's say these are the similar triangles. Also, it is given that area of triangle ABC is equal to area of triangle DEF. It is given, isn't it? So let's start with the proof. Now, as triangle ABC is similar to triangle DEF, we can say that area of triangle ABC by area of triangle DEF is equal to what? Squares of the corresponding sides, isn't it? That is AB by DE, the whole square, which is equal to BC by EF, the whole square, which is equal to AC by EF, AC by DF, the whole square. Okay. So from the given data, we can write this. Okay. But instead of area of triangle ABC, we can write it as area of triangle DEF because both the areas are equal. So we are replacing it, ABC by DEF. Okay. Area of triangle DEF is equal to same stuff, AB by DE the whole square, which is equal to BC by EF the whole square, which is equal to AC by DF the whole square. Okay, both gets cancelled and we are left with 1. So 1 by 1 is equal to AB by DE the whole square, BC by EF the whole square, which is equal to AC by DF the whole square. Let's take the other side. So here, so all this 1 is equal, 1 by 1 is equal to all the 4 things, right? So we can take any 2 of them, isn't it? Let's take these 2. Let's take these 2. Okay, all 4 are equal. We can take any one of them, isn't it? So 1 by 1 is equal to AB by DE the whole square, isn't it? If the square goes the other side, it becomes square root of 1 by 1 is equal to AB by DE the whole square. Square has gone the other side. So it will become root of 1 by 1 is equal to AB by DE. So square root of 1 is 1. Again, square root of 1 is 1. So you get AB by DE. Okay. So which implies if you cross multiply it, you get DE is equal to AB. Okay. Let's take it as equation 1. Now in the similar manner, if we take the first 1 by 1 and the other 1 by 1 is equal to BC by E of the whole square, definitely will end up as BC equals EF, isn't it? So let's take it as equation 2. Similarly, in the same fashion, if you take the first one and the last one, we get AC equals DF, isn't it? Let's take equation 3. Now, if you observe equation 1, 2, 3, okay, that is DE is equal to AB, EF is equal to BC, and DF is equal to AC. Now, what is this? 3 AB, BC, AC are 3 sides of one triangle. Let me highlight it with a different color. AB, BC, and AC are 3 sides of one triangle. DE, EF, and DF are 3 sides of another triangle. So therefore, we have got 3 sides of one triangle is equal to 3 sides of another triangle, which implies triangle ABC is congruent to triangle DEF using SSS postulate. Okay, that is, if 3 sides of one triangle is equal to 3 sides of another triangle, then we can say those 2 triangles are congruent, isn't it? So that's how we have proved this. Let's get into the next question. Okay, the next question is question number 5. So we'll continue in the next video. Question number 5, 6, and 7. We'll do it in the next video. Thank you, students.